Stealth technology has become one of the most important aspects of modern military aviation. And today, we're going to take an in-depth look at one of the stealthiest fighter jets on the planet. The Sukhoi Su-57. Developed by Russia's leading aircraft manufacturer, the concern Radio Engineering Corporation, or RSK, Bezimianaya, the single-seat, single-engine Su-57 is designed to perform both air superiority and strike missions deep within hostile airspace, capable of carrying a variety of air-to-air and air-to-surface weaponry. The multi-role platform was first unveiled in 2000 and made its first flight in 2010. Officially adopted by the Russian Air Force in 2020, it remains one of only two operational fifth-generation fighter jets outside of America, the other being China's Chengdu J-20. In this video, we're going to take an in-depth look at this fearsome Russian fighter jet, starting with its stealth design, which, like all stealth platforms, prioritizes the reduction of visual, aural, and thermal signatures. In order to reduce its radar cross-section, or RCS, the Su-57 features a number of serrated edges and flat surfaces. These include the removal of panel lines, which are typically used to indicate where two or more components join together. In addition, the air intakes have been designed to avoid the formation of large radar reflectors. The cockpit has also been designed to minimize its RCS. For example, the canopy or windscreen has been designed with a wedge-like shape to deflect radar waves away from the fuselage. Additionally, the jet's engine and electronic systems have been shielded to prevent their heat signatures from being detected by enemy sensors. The Su-57's stealth features don't end there. Its special materials also play a key role in reducing its RCS, unlike fourth-generation fighter jets, which often use metallic materials for their airframes. The Su-57's airframe is primarily composed of composite materials. These materials, such as carbon fiber and fiberglass, are less reflective of radar waves when compared to metals such as aluminum. The Su-57 also uses radar-absorbent materials, or RAM coatings, over its airframe. This material soaks up incoming electromagnetic energy, or radar waves, reducing the aircraft's RCS. Another feature that reduces the Su-57's RCS is its use of embedded or flush-mounted munitions. This means that the fighter can carry its weapons without them protruding from the airframe. This helps to prevent the weapons from acting as aerials, which can give away the aircraft's position to enemy sensors. Overall, the Su-57's stealth capabilities make it difficult to detect, track, and engage, making it a formidable opponent in any engagement. But the Su-57 isn't just about stealth. It also boasts a number of other impressive features, starting with its incredible maneuverability. The Su-57 is equipped with thrust vectoring engines, which allow the pilot to control the direction of the engine's thrust. This gives the aircraft the ability to perform a wide range of aerial maneuvers, such as super and subsonic aerial maneuvers, including the infamous Pugachev's Cobra maneuver, made famous during the Battle of Grozny, because they allow the plane to literally fly backwards while maintaining controlled flight. Thrust vector control also allows for extremely sharp turns and rapid acceleration, making the Su-57 a formidable opponent in close quarters combat. In addition, the Su-57's use of composite materials and advanced manufacturing techniques makes it incredibly light for its size, giving it an impressive power-to-weight ratio and further enhancing its maneuverability. Moving on, the Su-57 is also equipped with a number of advanced sensors and electronic systems. For example, it features an active electronically scanned array or AESA radar, which provides greater accuracy, range and tracking capabilities than older radar systems. The fighter also has an integrated sensor platform known as the NO36, which combines the functions of the radar, electronic countermeasures and data link into a single system. In addition, the Su-57 has a number of onboard computers that process data from various sensors, allowing for advanced targeting and weapons guidance capabilities. Furthermore, the Su-57's advanced avionics suite includes the use of a higher-resolution multifunction display in the cockpit. This display provides the pilot with a high-level situational awareness, allowing them to easily identify friendly and enemy aircraft, as well as potential threats on the ground or in the air. Next, let's discuss its weapons, which are a testament to the versatility and lethality of this fighter jet. The Su-57 can carry a variety of air-to-air and air-to-ground weapons, making it a true multi-role platform. For air-to-air combat, the Su-57 can be equipped with the R-77 or RVVA air-to-air missile. These long-range missiles are designed to engage enemy aircraft beyond visual range, giving the Su-57 a significant advantage in air-to-air combat. In addition, the Su-57 can carry shorter-range infrared homing missiles, such as the R-74M2, which are effective against a wider variety of targets, including aircraft, UAVs, and cruise missiles. These missiles are particularly effective in situations where enemy aircraft are attempting to evade detection by flying in areas with heavy electronic countermeasures or ECM jamming. For air-to-ground missions, the Su-57 can carry a variety of guided and unguided bombs as well as air-to-ground missiles. One notable weapon is the KH-32 cruise missile, which is designed to engage a variety of targets, including those heavily protected by air defenses. In terms of hardpoints, the Su-57 has a total of 12, which are distributed across the airframe. 6 are located on the wingtips, 2 under each wing and 2 under the fuselage, which can accommodate additional fuel tanks if required. The remaining 2 are situated on the sides of the cockpit and are primarily used for carrying air-to-air or air-to-ground weaponry. Let's now talk about the engine that powers this beast. The The Su-57 is equipped with a single Saturn AL-41F afterburning turbofan engine. This engine is a highly advanced power plant that is specifically designed for the Su-57. It boasts a high bypass ratio, which improves fuel efficiency and reduces emissions. The engine also features an innovative dual-shaft design, which improves reliability and reduces maintenance requirements. In addition, the AL-41FN engine is capable of afterburning, which means that it can ignite fuel in its exhaust stream, increasing thrust for short periods of time. This is useful for a variety of applications, including taking off and landing, as well as engaging in high-speed aerial maneuvers. Overall, the engine's performance characteristics make it ideal for use in a stealth fighter jet such as the Su-57. Now we come to production numbers. Despite being developed in the early 2000s, only around 10 examples of the Su-57 have been built so far. This is due to a number of factors, including the complexity of the aircraft's design, as well as economic constraints. However, it is reported that Russia plans to produce up to 76 of these fighter jets. Finally, let's address the elephant in the room. How does the Su-57 compare to the American F-35? Both are fifth-generation fighter jets with advanced stealth capabilities and a high degree of maneuverability. However, there are some key differences between the two platforms. First, the Su-57 is larger than the F-35, which means it has greater range and payload capacity. Second, the Su-57 is designed for air superiority missions in contested airspace, while the F-35 is designed for a variety of roles, including intelligence gathering and special operations. Third, the Su-57 is more expensive than the F-35, which has been in production for several years and has already been exported to a number of allied nations. Overall, the Sukhoi Su-57 is an impressive feat of Russian engineering and one of the most advanced fighter jets in the world. Its stealth features, advanced sensors and electronic systems, as well as its powerful engine and airframe, make it a formidable opponent in the skies. While its production numbers are currently low, it remains an important platform for Russia's military and one that will likely continue to be developed and improved in the years to come. Thank you for watching, and I hope you enjoyed this video. If you liked it, please leave a like and subscribe for more content.